Hello there, this is Bradley again, and you're listening to Psych Everywhere, a podcast brought to you by Psi Chi, the International Honor Society in Psychology. Let's start this episode on a totally different note. The music clip that you're listening to right now is of Johann Sebastian Bach Orchestral Suite No. 2 in B minor, which is available in the public domain. About this audio track, here's an interesting thought. I think it'll pique your curiosity. Is the music, as you're hearing it right now, the same as someone else might hear it? For this episode, we're going to delve into psychoacoustics, starting with the effects of your skull on sounds you hear and even your preferences in music. And as if that's not interesting all on its own, after that we'll sort of work our way out from the skull to discuss other influences on our perceptions of sound. Pretty cool topic for a podcast, right? With me today is Dr. Michael Hall, a professor in the Department of Psychology at James Madison University. Dr. Hall is an expert in psychoacoustics, particularly in establishing perceptual principles that people use to recognize common auditory events like speech, musical instruments and structures, and environmental events. As it so happens, Dr. Hall was actually also president of Psi Chi in 2010 through 11, during which time the organization had only recently become international as we know it today. This was also the year when Psi Chi worked on expanding awards and grants and launched a diversity task force. Later on, we'll discuss a bit more about Dr. Hall's presidency too. And he's also, by the way, a co-editor of a Taylor and Francis journal he helped found called Auditory Perception and Cognition. Dr. Hall, it's my honor to welcome you to the show today.
Well, thanks for having me.
I'm going to just jump in the questions because I have a lot of questions, it seems like. And
fire away.
First things first, here's my big question. Does the skull affect your music preferences? What did you find?
Well, that is the $100,000 question right there. We've taken a stab at this, and by we, I'm really giving a nod to the first author on the project that you're talking about, Mike Gordon, who's at William Patterson University in New Jersey. Mike was interested initially in that very question and tried to test it himself using limited equipment that he had available to him. You need a way of being able to transduce the sound. You need a bone conduction microphone to be able to see what the skull is actually picking up on. And that needs to be captured as something separate from what comes through our normal way of listening, which is what we call the ossicular chain. It's the bones in your middle ear. You know, your eardrum vibrates and you have this sound conducted through these little bones directly into the cochlea, your inner ear. This bone conduction process of going through the skull bypasses all of that and dumps it right in your middle ear cavity, right next to that cochlea. So that's just a small percentage of the sound that actually gets in there. He was interested in whether that would affect listening preferences and initially tried to test this with very mixed results because he couldn't get really good measurements from the equipment that he had. So I got involved in the project with him when he presented this at a conference, and we said, maybe there's a better way that we could capture that. If we could measure what energy pattern actually gets through the skull and quantify how much difference that makes from one person to the next, that would be really good and get us closer to that mark. So the first step was to get a good recording. Mm-hmm. A colleague, Jeremy Gaston, who incidentally trained and graduated from the same laboratory I did many years after I was there, but we'd known each other for many years. And he works at the Army Research Laboratory. He had access to all this audiology equipment and the audiologists who regularly conduct those kind of bone conduction tests. So we did a lot of recording. I suggested we pass what's called white noise, which is just random energy across all the frequencies. So basically you have the same intensity at all the frequencies. So it's nice and flat and you know what you're putting in there. we recorded that over several seconds and played that through people's heads and recorded that, and found that individuals were receiving very different things through their skulls. There were certain frequencies across listeners that would come out as particularly intense, and others that would come out as severely attenuated or reduced. But there are also huge individual differences, somewhere on the order of like 20 to 30 decibels at a given frequency. To give you an idea of how much that is, 6 decibels is doubling the pressure hitting your ears. So if we're talking 20 to 30, that's massive. Well, that still doesn't answer the question about listening preferences, this nice innocent question that you started with, right?
Right.
That's how much difference is there in the bone conduction itself. So we did a second test. We tried to devise a series of filters in the lab that we could impose different adjustments to the intensity of each frequency region based on what we had measured from the listener's skull. And then played that back to people and asked if they preferred one over the other. We got massive differences there, but it wasn't really a fair test. The problem with it was that we were only playing what was essentially an approximation to the bone conducted signal. We weren't getting any of the mix in with what they would normally hear, which is like 90 or 95% of what gets through is through the air conducted pathway through those bones in the middle ear delivered to the cochlea that I was talking about. Mm-hmm. So we were left with questions. Was this really a fair test? Our conclusion was no, we need to do a better job. So what's happening right now, I was actually even looking at this morning, is devising a better way of testing this out. We're planning on doing some data collection very soon with a follow-up project. What we did relative to this is devise a better set of filters that matched how we were collecting the data in the initial bone conduction study, so that we could divide it up into what they call third octave bands. These are frequency widths that are essentially like processing units in your inner ear are argued to act. And so this should be perceptually a very meaningful way of manipulating sound. So we have a bank of these filters that we can control to approximate what we had recorded from all these listeners. What we're going to do is mix that in with the normal sound that would get through in the typical path through the ossicles and play that to people. This difference should be much more subtle than what we presented before. The question is, will people be able to detect that difference and use it? If they can, then the next step is to go to listening preferences. So the first thing we're going to do is, can they detect differences in very simple sounds like basic tones? And then we will move forward with a full-fledged listening task for something like a piece of music, which is where Mike started. So it only took us 4 or 5 years to get back to the same idea that he had started with.
Awesome. Well, thank you for kind of going into depth on that and sort of your process. Or I know when I first saw the title of this study, and the study we're talking about, it was published in 2015, and it's called Skull Preferences and Musical Listening Preferences. And the music that they used in it, some of the music was the Bach song that I played for you earlier, just so we can kind of tie all that together for you. But I appreciate you giving me the process, because when I saw the title, I genuinely pictured you lined up all the participants in rows from the smallest heads to the biggest heads, and you got out some xylophone mallets and you just played a wonderful tune. And I thought, man, I bet you there's a cool process to this. There's so much about sound that I don't totally understand of the sound that's going through the bone. What is it exactly that's sort of influencing people's perceptions? Like, is it the thickness of these bones, or the size, or composition, or?
Well, at its most basic level, you can think of the skull as really just a certain size and shape could potentially resonate, right? It's a surface that you can present sound to that can vibrate or convey the sound through that chamber of the head. Now, it's not empty, it's filled. And so the fact that it's filled is also going to absorb sound and affect how it's transmitted. But the fact that each of us has a different size and shape head should impact how that sound is going to translate through the bone differently. I think of it similar to like a different instrument size and shape. If you're playing a different musical instrument, if you pick up one acoustic guitar versus another, while they're both guitars, they will not sound the same. The materials are a little different, but the sizes and shapes and choices of how everything is going to be created there is going to be a little different. The same is true of human skulls. That uniqueness that they have will impact how that sound is going to transfer around the head. If you play a sound directly to the skull, some of that transmission is going to be lost because the bone is not the best vibrator.
Okay.
Meanwhile, you will get a lot of energy being, as long as it's continued to be conveyed to the skull, a lot of that energy will transfer. The question is, what is that pattern? The pattern is going to be determined by, you have several plates, bone plates, and how well they're fused together, what's next to them, right? What the relation is to them, how far they're spread apart. So you can think of the larger the cavity, then typically that's also going to impact like driving frequencies lower that might convey better. Does this give you a basic idea?
I think so. It's complex. I'm not going to lie. I have to really try to picture the skull and the things happening. So you co-authored a more recent article published in 2019, and this one was even more complex. But let's pick at the what I think were the main findings, and I'm going to read it exactly. It said the skull's response patterns correlated with an individual's bone conduction thresholds, but not their air conduction thresholds.
Yeah, so we were talking about the two different kind of ways of getting the sound
right
in your ear. The bone conduction threshold would be measuring a threshold of a sound being conducted through the skull, whereas the air conduction threshold is the more traditional way of just directly through the ears and the ossicular chain in the inner ear. So the odd man out there, the weird one, is the bone conduction signal, because only a certain portion of the sound gets through normally that way. But as long as we're talking about different patterns of energy conveyance as a function of the skull, we would expect any of those individual differences really to impact bone conduction thresholds. If we're only delivering the sound in that way and not letting it get through in the more traditional way through the ears, then we would expect that to be predictive. The fact that we tested those perceptual thresholds for these sounds at different frequencies, and it mattered for bone conduction, but not for air conduction, suggests that there's a possibility here that listening may not depend quite so much in a normal complex situation where we get it in the typical way, might not depend too much on that bone conduction signal. Had it directly impacted those air conduction thresholds, then I'd say that was pretty definitive right there. But now that leaves the whole question of what we're able to get from that bone conducted signal as an open question. It might matter in some circumstances and not in others. For example, it will certainly matter when you are speaking. Right now, I am hearing the sound of my voice being conducted through my skull as I produce it, and then again coming back in from the outside back in. I'm getting bone conducted signal twice. So it's definitely going to influence my perception of my own voice under those circumstances.
I had a question about that. So while you're on that topic, I guess you've maybe explained it. So obviously when I hear my own voice, it sounds like nails on the chalkboard when I hear a recording of it later. So I suppose that it's simply what you're saying here, that you're not hearing it twice, basically. Is that right?
Yeah, most people don't like the sound of their own voice played back to them because they lose that warming effect of bone conduction from their own speaking process. So think you're generating the sound inside your head. It has to escape through the skull to get out there. So you're getting a bone conducted signal before it is even released into the world. But
that's
listening
cool.
to it again, which means a certain percentage is going to be bone conducted back in. That basically fattens up the low frequency end of what you're listening to and makes it sound pretty sweet.
Let's start heading outward in sort of the bigger picture, like I promised, because this is just a fraction of what Dr. Hall's research is about. What are other things entirely that are affecting sort of how we're hearing and perceiving sound? I mean, obviously distance, but I'm sure there's a lot more.
Well, sure. One of the things that you could think of is just the fact that you're not listening in a vacuum. You're listening in an environment, and that environment has a lot of different events that are going on at any given time in any ecologically valid situation that we could be talking about. So when a person is speaking, you're often hearing them amidst some sort of ambient noise, but there also could be spontaneous events that could impact whether people are going to be able to pick up on some of what's being conveyed or not. The way we listen, we're listening, I think of us as frequency specific listeners. And if we're trying to pick up on energy, the ear is trying to pick up on energy in specific frequency regions. If you have multiple sound sources that are presenting energy in the same frequency regions, then they're competing for the same resources. The same hair cells, these receptor neurons, are competing for the same information. So they can't have it both ways at the same time. It's either firing in response to one source or another source. It's picking up on frequencies from one place or another place. So all of that's going to interfere with our ability to be able to get a really good sense of everything in a complex listening situation. We also have limits to the information that we can pick up on. And those limits are going to change not only as a function of individual physiology, but over time, that physiology will change just because of how we treat it. I, for one, have spent a lot of my time listening to and playing loud, raucous music. Well, if I'm producing a lot of loud music, that's impacted my ears negatively over time. So I'm not able to pick up on a lot of the higher frequency information near as well as I used to when I was younger. This is true of everyone to a degree. We lose that high frequency information as we age. It's just a question of how fast that happens for each individual person.
Taking this back in the direction of applications of psychology, I like to ask, like, well, what can we do with it? Can this information be used to influence or, I don't know, modify people's behavior or apply to technology, marketing? I'm sure there must be some interesting things people are doing with this.
A lot of times when people see basic research like this, they have trouble seeing the immediate real world application. It's true of most areas of basic research in psychology that people struggle with that. But there are a lot of real world applications for this kind of stuff. For example, people who do research in how we process complex sounds like speech and music, and my laboratory is interested in these kind of common auditory events. They'd be interested in ultimate real world applications like creating text-to-speech capability that's more effective, typing a message and being able to have it be understood, whether it's in your native language or not. Imagine the creation of a universal translator. Imagine somebody being able to produce speech who couldn't otherwise produce speech just by typing in a message and have it sound reasonable. Alternatively, the backside of that is automatic speech recognition. You could actually have information picked up on by microphone and be able to translate that into something that could be understood, even if it's in a language you don't understand. Speaking to your computer, your computer has capabilities of being able to pick up on some simple voice commands now. A lot of people don't know that's in there, and they don't know they can activate that. And a lot of people that do activate it are very disappointed with the results, right? It keeps people like me in a job. But the problem there is one that we definitely want to tackle, because if we could make these machines be able to recognize what we are intending, think how much easier it will be to be productive. We won't have to labor near as much to get the products that we're after. So these will be great simplifying tools. Now, on the music side, you could think of like how we create sounds that people like to listen to is largely dependent upon people understanding the research behind it. How do you make sounds that sound reasonable? If we want to design a synthesizer sound for some EDM music, for example, that approximates a real sound source, like a natural sound source, like strings, for example, or a bass, there are certain parameters that need to be known to make that happen. And there are ways to do that to make it sound more natural or less natural. Some of my colleagues, a guy I'm collaborating with, for example, Jim Beauchamp, he was one of the initial people to develop a voltage controlled synthesizer, but he's an academic who is interested in timbre or sound quality research like I am. He literally wrote the book on how do we synthesize sounds. If we understand that process and how the listener is going to be able to use chunks of information from that and understand the perceptual side too, think how powerful the music we could create would ultimately be, even if we're using artificial sound sources to do it. Now, what about everyday life? How about something like a warning signal? If somebody needs a sound to generate enough attention to tell them, hey, don't walk out on that train track right now, that would be a bad idea. Then we need to know what the parameters are of sound that will give rise to the fastest reaction to say, don't go out on the tracks. A typical example also is an air traffic controller. Traditionally, they used to use that as an example because the air traffic controller is bombarded with lots of different voice messages, and they have to be able to parse them all out and keep track of them to make sure nobody's going to, make a mistake and with really nasty consequences. So if we can understand how we can maximize that separation and make it so that people can attend to all of those streams of sound separately and not lose the information, not get it to interfere with some other sound source, think how wonderful that would be. A lot safer environment we're creating. So does this give you a few examples?
Yeah, and I was even thinking about like emergency broadcasts and that awful, frightening, uncomfortable sound that you hear at the beginning of them, that duh, duh, duh. I was thinking, like, have we learned to be afraid of that, or was that always something we were afraid of?
I suspect that sound was created before they actually knew what about it was really grabbing people's attention. But there are lots of parameters there that we get to play with, all of which could impact the sound in some way. The fact that it's pulsing or changing over time, so it has dynamic qualities to it. The fact that it is intense relative to other sounds is also that increase in loudness perception for us is going to help us be able to separate that out from other sounds in the background. The fact that it's complex, that it's made up of lots of frequencies at once, maximizes the chance that we're not going to lose it if there are other sounds going on in our environment right then. All of those parameters are important.
How did you become interested in psychoacoustics?
Long story that I'll try to make relatively short, but I hope that at least a few Psi Chi types are going to find this interesting in terms of figuring out their own path in life. Going into undergraduate school, I was faced with a decision. Do I want to go into psychology, which I was very interested in, or do I want to pursue music? I grew up in a house where my mom was a concert pianist before she settled down and got married. And I was always interested in music. So I said, music, performance, or psychology. That was the dichotomy I was setting up for myself. And I chose psychology because I thought there was greater job security in that. I was young and naive. I really didn't know what to think at that point. But then as I went through the psychology major, I was originally thinking clinical psychology, and I started to question elements of clinical psychology for me personally. I realized that, maybe I couldn't do clinical work for several years and have it not impact me personally in some way, that I would be taking my work home all the time. I think it takes a special type to be able to be a clinician. But I also found out that I was asking a lot of questions about the process of how things worked, what therapy did. I wanted to understand the system of the human being. And that led me ultimately, by accident, to be truthful, to perceptual things. And I was doing research one day for a paper for a class. Back in those days, you had to do this in the library stacks where all the books were. You had to go to where the sources were. And while I was looking for sources that would help my paper out of the corner of my eye, literally, there was a reflection off of a brand new book that was momentarily blinding. And I'm not exaggerating, but I wanted to know what that was doing that to me to make it stop. So I went over to the next shelf to look, and it was a brand new book called The Psychology of Music by Diana Deutsch. And since that time, I've talked to several of my colleagues who were in the music perception field, and they read that book at the same time I was reading that book, and it affected how they went about things from there on too. I ultimately was able to talk to Diana Deutsch, the author, a couple of years ago at a conference, and tell her that, oh, by the way, thanks for changing my life in 5 minutes. I switched directions as a result of that, because I realized by reading this book that my choice at the beginning of my undergraduate time was a false one. I was thinking I had to do music or psychology. I didn't realize there was such a thing as music psychology, but it had been around before it was even called psychology. It predated the origins of experimental psychology in Wundt's laboratory. Before that, there was this psychophysical stuff that was being done, including on music. So I realized, well, wait a minute, maybe I could combine my interest into some sort of niche career for myself. And that started me down the road of looking at perception things.
So when did you become a Psi Chi member? Were you an undergraduate or?
Oh, this is an admission of guilt story, actually. I was not a Psi Chi member as an undergraduate because in my silliness, I thought that all honor societies were elitist groups and that they were really just wanting to take my money and they weren't there to really prepare me for anything. So the heck with them. That was my attitude.
See, that's a perfect person to become the president, I think. Yeah.
Right. So I realized there was nobody that was actually steering me straight early on. But then I became a Psi Chi member as a faculty member when I was able to see some of the things that the local chapter were involved in. And I had an opportunity to become a co-advisor. And I couldn't co-advise the group that was really doing pretty neat stuff. They were getting good opportunities for research, and they were also helping in the local community. And I couldn't get involved with any of that without becoming a Psi Chi member. So I did my due diligence and I looked into the organization, and I realized this particular honor society was not just a stamp on a transcript. This was something that was actually giving people an opportunity to prepare for a career in a field that they cared about.
Hear, hear.
And as an honor society, while it has academic requirements, it's not trying to be completely exclusive. It's trying to bring in all the people that are likely going to keep pushing forward in the field of psychology as their chosen profession, right? Just by what traditionally happens. So that kind of locked me into it. And once I connected with people who were board members, Chris Koch was one of the first folks that I made contact with, and he and I still room share at the Psychonomics Society conference every year. He was president a few people before me when he was a regional VP for the Western region. I was able to meet with him during an advisor event and found out some of the opportunities that could be created for students through the organization. And that committed me to really get more involved.
A lot of things were happening in Psi Chi the year that you were president. Not only were they just becoming international, but Origin Grants expanded a lot. Now, was that the year that they started having a lot of graduate level and things that was, I imagine you had some influence on that, didn't you?
That was kind of the platform that I ran for president at the time. I recognized that as a student organization, we had the capacity with the money the organization had to be able to increase the number of opportunities for students. So if we could give more of the money that was coming in from students back to those students, then that would maximize their return and get them ready for that next step of their career. But part of that was that there were really no specific opportunities for graduate students who had specific needs. A lot of them weren't going to the regional meetings of APA. Most of them were going to more specialized conferences that were in their chosen specialty area. For example, Psychonomic Society that I mentioned is the biggest of the experimental psychology conferences. But there was no way to give Psi members who were presenting at those meetings money beyond just a generalized travel award. And so we created kind of separate pools of money for both undergraduates and graduate students, and that it could be not only for regional meetings, but for more specialized meetings as well. And that was separate from any kind of money that they needed to support research that was in progress, separate from the travel awards. So that was something that we were really interested in making happen during that presidential year. I was the second president when it became international. So there was definitely some stuff that was in flux at that time. And I remember that being one of the busiest meetings that I ever attended on the board in terms of the number of changes that were having to be considered. But that also made it a really exciting time. The other thing that came out right around that time was Psi Chi was finally starting to come to terms with making sure that it was going to pay attention to diversity as an organization. And so they created not only opportunities for students who were investigating those kind of issues, but also having dedicated personnel, a director, to be able to foster things like research that looked at those issues. And we're also developing policy that will be able to end up helping foster the benefits of diversity within the organization. And so I view that as kind of another really exciting thing to come out of that same time period.
We got an email today from our membership coordinator. There actually was a new international chapter today that was board approved in Bogota, Colombia. So welcome
Nice.
from Bogota. Yeah, I know. I thought that was nice timing. So my next question, did you have any memories that you'd like to share from Psi Chi?
I've got lots of great Psi Chi memories, but generally speaking, I would say my fondest Psi Chi memories tended to be not only in interacting with board members, but also in interacting with students, usually through conferences or specific board meetings where we could see benefits for the students. Meetings, for example, with all the individual chapters and being able to see the excitement of students being able to interact with each other, being able to hand out award money at conferences and seeing students be really appreciative of that and recognizing how that could help further their cause in their research that they're looking at. But there were also some unusual memories that were really interesting. For example, I mentioned Chris Koch. We had conference planning that we did for regional meetings. And while he was VP, or he may have even been president by that point, and I was involved in the board, we actually had sessions that most Psi Chi regions will have sessions at these conferences. They'll be targeted specifically at students, how to apply for graduate school, for example, or different options in terms of careers that are available, mentoring, lots of different issues that were being talked about. But one in particular I remember was we were talking about different varieties of experimental psychology programs and explaining some of the things that students need to consider there and what to expect, what that would be like. Chris started the session off with variants of the Jeff Foxworthy jokes that you may be familiar with, but they were about graduate school. You're a graduate student if, and, or when this happens. And he had several varieties of them, and the response wasn't quite what he was expecting. There were a few laughs, but most of the snickers that were coming were from faculty members. The students who were in attendance didn't find it funny at all. And we weren't sure what was really going on. But after the fact, we had a good laugh, realizing that that's because the students hadn't experienced any of this firsthand. The people who were laughing were the people who realized, oh yeah, a lot of graduate school was like that. But I remember having a session like that where it didn't go completely according to plan. And then the next year at the same region, we had a meeting about the application process where we had students pouring out into the hallway because they wanted to absorb that information. Or when we had a guest speaker like Elizabeth Loftus one year, and we knew it was going to be crowded, so we got a room that would hold 400, and that wasn't enough. We had, people spilling out into the hallway. Those are interesting memories. Those are fond memories. I'd say the thing that sticks with me more than anything else, though, is realizing the things that happened while I was on the board that created opportunities for other students. Once those situations occurred, then I said, now we know somebody's going to benefit directly from this.
About the psychoacoustics, is there anything that you'd like to add there about your work or particular different studies? Do you feel like we kind of captured kind of the essence of that before we run out of time?
We talked a little bit about skulls.
Right.
Areas that we're involved in. A lot of people consider me a timbre researcher, which think of it as like how you recognize sound sources. Oftentimes I'll focus on musical instruments there, but I'm interested in general principles, as you talked about earlier. So a general connection then to something like speech might be how we categorize a phoneme, a sound that could distinguish words in our language, might be based on the same kinds of properties. So we'll spend a lot of time manipulating those properties in the laboratory. We actually create some software tools that'll allow us that extra degree of control. And we've made them freely available on my laboratory website for other researchers to make use of. And many of these devices are presented in a way where they're built for a recording environment that electronic musicians use. And so I have a lot of people downloading these things who are actually electronic musicians who aren't necessarily interested in research, but want to bend this tool to their will for a completely different purpose. So we're involved in some of that. We've looked at attention a little bit. So this gets more cognition involved. So how do you distinguish between sounds in a complex environment? When do you make mistakes about the sound sources that you're listening to? We've done studies of what's called change deafness, where the sounds are presented at a level that's well above what's required for detection, and yet people will make mistakes in simple judgments about them. For example, if I give you the same 4 sound sources spread about your head and you're listening through earphones, and one of them starts to move back and forth, under certain conditions, I can make it so that you're unaware of which one is actually doing that. You know something's changing, but it takes a long time for people to make that judgment under the right conditions. So this kind of change deafness could show us something about our own perceptual limitations or our ability to attend to complex scenes. We've looked a little bit about speech categorization kind of work, and also some things related to that. For example, I'm collaborating with Vivian Chan, who is at the City University of Hong Kong now, and we've been looking at perception of foreign accent. That's her area of expertise. And recently we've been looking at, like, why is it that people, when they sing in English, often have their foreign accent disappear? And so we're actually manipulating parameters that could potentially impact people's judgment about how accented a person's voice is. So these basic concepts send us in a lot of different directions. If people are interested, they can always dive in on our laboratory website and take a peek for some brief descriptions, or shoot me an email about that. If we can give them my email address with the podcast, then they'd be able to follow up with me about any of these specific projects that they might be interested in.
You've just listened to another episode of Psych Everywhere. If you'd like to see either of Dr. Hall's studies that we addressed in this episode, I've included links in the show notes. Also, if you'd like to hear more from Dr. Hall, you can listen to a recent episode on the Across Acoustics podcast, which he recorded with Dr. Jeremy Gaston. For that episode, they also talk about the Skulls and Music Preferences article. I'll leave a link to that in the show notes for this episode too. This year, we've been covering some of the more serious and sort of emotionally heavy topics regarding race, COVID, and gender. So perhaps you've enjoyed this fun change of pace for the last couple episodes. If you leave this episode with one new insight, I hope it's this. Psychology really is everywhere, even in a wooden xylophone mallet, bonking against the old noggin. Sorry, maybe that last line sounded better in my head. Get it? I gotta say, I really am blessed to be able to have the opportunity to work on this show and say fun things like that. Okay, everyone, that's all for now. I'll talk to you again soon. Copyright 2021, Psi Chi, the International Honor Society in Psychology. All rights reserved. The Bach music you listen to in this episode is available in the public domain and was accessed via Muse Open, a nonprofit dedicated to setting music free, and also the European Archive Music.